Hello everyone. Let us start with our next topic, that is directed graph. So for directed graph, let us start with the topic graph. So we can classify graphs like this: undirected graph and directed graph. Directed graphs are also known as digraph. As the name suggests, undirected graphs are the graphs in which edges has no direction. Not even a single edge has a direction. But in directed graph, all the edges have direction. For example, here, this edge has a direction. It starts from A and ends at B. Similarly, for this particular edge, it starts at B and end at C. For this edge, it starts at C and end at B. So all the edges has a direction. Then this graph is said to be a directed graph. If the edges has no direction, then it is said to be a undirected graph. Let's go to the definition. Graph in which each edge has a direction. Now the given graph is a directed graph since each edge has a direction. Starting vertex or the initial vertex. Suppose A and B are vertices and it is an edge. So it starts at A. This vertex A is said to be a starting vertex or the initial vertex. And it ends at B. So this B is called the terminal vertex. Next come our topic, degree of a vertex. So we learned in this topic, undirected graph, that degree of A is all the edges incident to it. So degree of A is 1, 2, 3 and 4. Degree of B is 1, 2 and 3. Degree of C is 1, 2 and 3. And degree of D is 2. But when we come to directed graph, we have two types of degree. In degree and out degree. So the vertices are A, B, C and D. In degree are the number of edges that are incident to A, and out degree are that is incident from A. For example, in degree, look at this. This is the vertex A, the edges that are going into A. So this edge is going into A and this edge is going into A. So in degree of A is 2 and out degree going out from A, 1 and 2. In degree plus out degree becomes the total degree of A, which is equals to 1, 2, 3 and 4. Similarly here B. In degree of B is the number of edges going into B. So 1 and 2. And out degree is going away from B, that is 1. In degree of C, going into C, going away, it is coming into C. So in degree is 1 and out degree is 2. For D, in degree is 1 and out degree is 1. Hope you well understand the topic in degree and out degree. Look at this. In this given graph, you can check the in degree and out degree. What is the in degree of A? The number of edges going away from A, that is 1, only 1. So in degree of A is 1, in degree of A is 1 and 2. These 2 and out degree is 1. In degree is 2, out degree is 1. Again, for B, going into B is 1, so in degree is 1, out degree is 2. In degree 1 and out degree 2. For C, it is going away from C and coming into the C, so in degree is 1 and out degree is also 1. And for D, in degree coming into D is 1 and 2. So in degree is 2 and out degree is 2. So this is in degree and out degree. Next is a theorem based on it. In a directed graph, let the name of the graph is G, where capital V denotes the set of vertices and capital E denotes the set of edges. Then the sum of degrees in degrees of all the vertices is equal to the sum of out degrees of all the vertices is equal to the number of edges. So look here. For the proof, we know that each edge has an initial vertex and a terminal vertex. Initial vertex, the vertex from which the edge starts, and terminal vertex where it ends. So in any directed graph, any directed edge contributes 1 to the in degree and 1 to the out degree, right? So obviously the sum of all the in degrees is equal to the sum of all the out degrees. But by handshaking lemma, we know that sum of all the degrees of vertices is equal to twice the number of edges. For having all the sum of all the vertices, degree of the vertices, it is same as the sum of all the in degrees of vertices plus the sum of all out degrees of vertices is equal to twice the number of edges. But this is equal to this by this point, right? So this is equal to this is equal to the number of edges. Hence we are done.